8.2, adding, subtracting rational expressions. So let's go to this worksheet. Find the LCM of each set of polynomials. So the way this works, the general rule to find the LCM is you want to take one of each. If two or more are the same, or the two or more are the same, take the biggest. I'll explain what that means in a second. Right, so let's look at these variables, right? So for my LCM down here, variables are by far the easiest. You take one of each. I need an x, so I take an x. Now they all have an x, so two or more are the same. So what do? You take the biggest one, x cubed. And what do I need next? I need a y. Well, two of them have a y. Which one do you take? Well, the biggest one, y cubed. You're not really taking, but it's just like that's what you need. Like you need the biggest one. So how do I do the variables? Well, there's a couple ways to do it. You could just kind of go 5, 8, 16, try to figure out what they all go into. It's like 5, 10, 15, 20, yada yada. 8, 16, 24, 32, blah blah blah. 16, 32, blah blah blah, right? Until they all match. So that's one way to do it. Other way to do it, the more proper way, is to do a prime factorization for each one. So like 16, that's 2 times 8, 2 times 4, 2 times 2. So this is 2 to the 4th. 8 is 2 cubed. 5, it's just 5. So you can also do it the same way we did the variables. Take one of each. I need a 2. Well, there's 2 of 2, so we'll take the biggest one. And then I need a 5. So my LCM is going to be 2 to the 4th, which is actually just 16, times 5, which would be 80. So my LCM here is going to be 80 x cubed y cubed. That's the way it works. So for the numbers, you just prime factor and you do the same rule. Take one of each, so this is all prime factored. So I need a 2, and I need a 5, but there's 2 2s, so you take the biggest one. 2 to the 4th times 5 is 80. And then for the variables, same idea, right? Take one of each, take the biggest one. Over here, it's a little different because it's like trinomial, so you got to factor it first. So this is going to be 2 to the multiply to get 20, but add to get 9, x minus 4, x minus 5. Here, 2 to the multiply to get negative 30, but add to get 1, so it's x plus 6, x minus 5. So we factor, and then we do the exact same rule. Take one of each. So I need an x minus 4, because there's one right here. I need an x minus 5, because there's one right here. Now they both have it. Take the biggest one, they're the same, so it doesn't matter. It's x minus 5. And we need x minus 6. There we go. That's my LCM. Okay, so now we want to add them. So when you add fractions, like adding numbers, you need the common denominator, or the LCM. So what's the LCM here? So I have 5x and I have 4y. Now this is actually a really basic LCM. You take one of each, so an x and a y, need both of them. The y happens to be cubed, right? Because it's whatever has the highest. And then 5 and 4. Well, 4 is 2 squared and 5 is 5, so LCM is going to be 20. So the LCM. And then you try to make both of these match by trying to get the LCM. Okay, well, how do I get 5x to be 20xy cubed? What's it missing? Well, it's missing a multiple of 4. It's missing a y cubed. So we'll multiply both top and bottom by that. Alright, we need a 4 to make it 20, and we need a y cubed since I don't have it. So I get 4 times 12 up here is 36. And I'll get a total of y to the 4th. Because there's already a y there and y cubed. Same thing over here, right? You have 4y cubed, you need to get to make it 20xy cubed. So, how do you get there? Well, I need to multiply by a multiple of 5, and I'm missing the x. So 5x, 5x. So I get 25x squared from the top. And that's pretty much all you could do. Now I'm going to combine it to make it one fraction, but I really can't combine the numerator. It just has to stay the way it is because they're different variables. So I get this. And that's the answer. Can't do anything about that. So that's the general idea. So we do the same thing here, right? I want to add all three. Just find the LCM of all three. So my LCM of 6 and 10. I mean, most of the time, by now you should just know what you should figure out by thinking about it. Where something 6 and 10 both go into, it's 30. If you want, you can break it down. 6 is 2 times 3. 10 is 2 times 5. Take one of each. I need a 2. I need a 3. and I need a 5. You get 30. Right, so you could do it that way, but if you just look at it, like, okay, we'll do 6, 10, both going to go 30. Now, how about the variables? Remember, you take one of each, so I need an a, and you take the biggest one, which is an a squared. And then I need a b, because there's a b right there. So I need a squared, b squared would be the thing right there. So all these are going to have the same denominator. Like that. Now, how do I get the numerator? Well, how do you go from 6a to 30ab? What's missing? Well, I need a 5. Right, 6 times 5 gets me 30. I need 1a because I have 1, but I need to get 2. And I need a b squared. Whatever you do at the bottom, you do to the top. Multiply the top here. 5 times 5 is 25. A, b cubed. Right, now you have a total of 3 b's. The middle one, you have 10, you need to get a 30. So I need to multiply this by 3 over 3. And I have a squared. I already have an a squared. I just need a b squared. So 3b squared top and bottom. And I get 9b cubed. Right, so again, to go from 10a squared to 30a squared b squared, you need to multiply by 3 to get 30, and you need to multiply by b squared. Whatever you do at the top, you do to the bottom. So you get that, 30b squared times 3b, 9b cubed. And then the final one here, you have ab squared. You need to get 30a squared b squared. So you're missing an a, and you got to get a 30, so multiply by 30. So 30 and an a is what it's missing. On top, you get 60a. And again, that's pretty much it. You can leave it like that. You can combine it all to one rational function if you want. Either way is fine with me. So either way works. But there you go. Next, we're going to do some more of these. So here, let's find LCM. So remember, I need one of each. So let's talk about the variables first. I need an x. They all have an x, but take the biggest one. And I need a y, because there's a y right here. How about the numbers? I have 3 and 5. They have nothing in common, so you just multiply them. 15. So there we go. That's my LCM. So I got to make 3 equations with 15x cubed y on the bottom. Now the first one, how did I go from 3x to 15x cubed y? What's missing? Well, you only have one x, and you need 2 more. And you need a y. Now how do you go from 3 to 15? Multiply by 5. Whatever you do at the bottom, you do at the top. Simplify this top here. So I get 20x squared y. One right here. Right? You have x cubed, but you need the 15 of the y. So multiply, that's easy. Multiply by 15y. Whatever you do at the bottom, do the top. So I get 80 plus 20, so 100. That's not right. 80 plus 40, 120y. I was doing 10 times 8 plus 5 times 8. So that's what I was thinking, 8 times 40. And then the last one here, you got 5xy and you get a 15, so I'm missing a 3 and an x squared. Right? I already have the y, but I need 2 more x's. So times 3x squared. And that top gets me 6x squared. And there you go. Again, if you want, you can combine it all to one fraction. Like that. Next one, 8 over 3y plus 2 over 9 minus 3 over 10y squared. We're going to do the exact same thing. My LCM. So I have, y squared. Take one of each, is only one variable, that's a y. And you take the biggest one, y squared. So now I got to think, what did 3, 9, and 10 all go into? So in tough one like this, you could think about it, what they all go into. 90 is the first thought I have. But if you're not sure, you can do the breakdown. 3, we got 9 is 3 squared, and 10 is 2 times 5. So it'll be 3 squared times 2 times 5. So it'll be 9 times 10, well, yeah, it's 90. So they all go into 90. So it's going to be 90y squared plus 90y squared minus 90y squared. Let me change the color. I've been doing green for a while. So now, over here, how do I get from 3y to 90y squared? What's missing? Well, it's missing a y, and it's missing 30, because if you multiply 3 times 30, you get 90. So 30y. Multiply the top, and you get 240y. The middle one, how do you go from 9 to 90? You times it by 10, and you're missing the y squared. So 10y squared. So you get 20y squared. 10y squared to 90y squared. So how do you go from 10y to 90? Well, it's missing a 9. Multiply that baby by 9. So you get 27. And then, again, there we go. If you want to run all as one fraction. All over 90y squared. And that's it for the first page. Now the second page has more, we're doing more with factoring. So it's the same concept, we just got to factor first. And we should take a little shortcut on these because it's when it's binomial, it's a little easier to tell with LCMs right away. So we get the factor first though. It's the factor of this. I need two things to multiply to get 18, but add to get 9. So that'd be 6 and 3. And if we're doing problems, it's probably gonna be one of these. This is one of the factors because you want them to match. Anyway, so that's it factored. So what's LCM? Well, basically I just kind of go, what does this guy have that this guy, what's missing from this guy that this guy has? That'll be the x plus 3. Right, my LCM here is going to be x plus 6, x plus 3. Take one of each, they both have x plus 6, and that one has x plus 3. So this side's already done. This side has something missing. It's missing the x plus 3. So my LCM is going to be x plus 3 times x plus 6 times x plus 3. But this side is missing the x plus 3. So you got to multiply by it to get x plus 3. There should be a plus sign, by the way. Sorry about that. This side is done, 4x. This side you got to distribute 5 times x, 5 times 3. So 5x plus 15. Now the denominators you always leave alone. You don't simplify, not worth it. Top, you do have to simplify though. 4x plus 5x is 9x plus 15 over x plus 6, 15. X plus 6, x plus 3. There you go. If you want to, you can actually factor the top. They both have a factor of 3, but it doesn't take you anywhere. Sometimes you want to do it because it might reduce with the denominator. In this case, no such luck. So something's like that. Okay, let's talk about how to do this a little faster. So we're going to do something here. We're going to factor real quick. Two things that multiply to get negative 16, but I have to get 8. X minus 8, x plus 2. Keep in mind, right, they're different signs. So the middle sign has to go to the bigger number. Over here, negative 40. So I need two things that multiply to get 40, but I have to get 3. So that'll be 8 again. X minus 8, x plus 5. Okay, so how to do this faster? Well, I look at it and just kind of go, what's missing? That's a little too close to what we're going to be using. Like, look what we have here, right? I have x minus 8, x plus 2. What's this side missing that this side has on the denominator? X plus 5. So you just multiply by what's missing. Look at this side. What does this side need that this side has? The x plus 2. So multiply by what it's missing. Now look at those denominators, right? They all match. Just multiply by what's missing on each side. You're good. You do have to simplify the top. We'll take a shortcut step also. We know what the denominator is going to be to make all of that put together. How about the top here though? I need 8 times x, so 8x plus 8 times 5, so 40. Over here on this side, I need 9 times x, distribute. And I need 9 times 2, which is 18. And I cut up like terms. 8x plus 9x is 17x. And then 40 plus 18 is 58. So x plus 5, x minus 8, x plus 2. There we go. Next one, just keep on doing the same process. So let's factor. Now again, some people always overthink this one. When nothing factors, when you're like, there's no binomial, not different two squares. What do they have in common first? They have a 3, x plus 2. And then this was the difference of two squares. X minus 2, x plus 2. So again, for me it's easy. Okay, what's missing here? I have a 3, I have an x plus 2. What does this need that this has? The x minus 2. It's missing an x minus 2. And look at this side, right? It has an x minus 2 and x plus 2, but what's it missing? It's missing a 3. So times it by 3. 3 over 3. So there we go. So I know my denominator is going to be, it's going to be 3 x plus 2, x minus 2. Right? Both sides have that. Now, the numerator you got to simplify. So 4 times x minus 2 distribute. So that's going to be 4x minus 8. Now here you got to watch out. That negative is very important. So this is more like negative 3 times x plus 1. That's what we want to think about it. That negative does matter. It goes into both of these. So treat it more like negative 3 goes to both of these. Distribute. You get negative 3x minus 3. Right, so there's a negative there. Now we just add up like terms. This and this and this and this. I get a single x minus 11 over 3 times x plus 2x minus 2. And there you go. This one, again, we just got to factor. Two things that multiply get negative 35, but add to get negative 2. That looks like y minus 7, y plus 5. Over here, we got a factor. Two things that multiply get 20, but add to get 9. That sounds like y plus a y. Plus 5, y plus 4. Right? And then next is, okay, what's this side missing that this side has? What's this side missing that side has? In this case, look at it. You're missing the y plus 4. Now over here, since you have the y plus 4 and the y plus 5, you're missing the y minus 7. We know what the denominator is going to be. It's going to be all that denominator. And the numerator you got to multiply, right? Distribute 6y plus 24. Positive 4 times y and minus 7, so negative 28. Out of like terms, you get 10y minus 4 all over y plus 4, y minus 7, y plus 5. I could reduce the top and factor out of 2. It's not going to take me anywhere, though. Nothing's going to cancel out, so I'm going to leave it like that. For next one. Now, this has a number front, but don't forget the general rule. See if they have anything in common first. These have a 3 in common. So you factor a 3, x squared plus 1x minus 6. And then that does factor. What two things multiply to get 6, but I have to get 1? 3 and 2. It's going to be 3x plus 3, x minus 2. Now over here, that's a tougher factor. You can't factor out a monomial from any of it. So you can't factor out a constant from any of it. So you have to do the long factoring. So I like to multiply the first two and last two. We'll do this over here and I'll erase it later. 2x squared times 15 gets me 30x squared. Well, two things that multiply to get 30, but add to get 11. That'd be multiply to get 30, but add to get 11. So not 10 and 3, 5 and 6. So 5x plus 6x. Sub it in for the middle. So it's going to be like this now. 2x squared plus 5x plus 6x plus 15. Right, we're going to sub this in for the 11 there. 11's gone, and these two are put in place, right? Because 5x plus 6x is 11. And now we factor by grouping. These have an x in common, so 2x plus 5 plus these have a 3 in common. So divide by 3, 2x plus 5. 2x, I don't know why I wrote 3, 4. There we go. These match. So 2x plus 5 times x plus 3. So that's my denominator down here. 2x plus 5, x plus 3. Now, right, so we have to add these, we need to find LCM. So what's missing from here that this side has? Only I see is a 2x plus 5. So this side, the multiply by 2x plus 5 and 2x plus 5. Now let's look at this side. What does this side have that this side needs? Well, it's missing two things. It doesn't have the 3 and it doesn't have the x minus 2. So I gotta multiply by 3 and x minus 2. That's kind of a pain. So, as always, I already know what my denominator is going to be. It's going to be all that whole denominator. 3x plus 3, x minus 2, and 2x plus 5. But to do the numerator, I gotta simplify all this. So let's simplify this one. 8x plus 20x. 8x squared plus 20x, sorry. 4x times 2x would be 8x squared. 4x times 5 is 20x. Over here, so I'm going to do this on the side here again because it's a little complicated. So keep in mind that negative goes with the number on top. So it's a negative 2x times 3 times x minus 2. So the easiest way to do this is, remember, the way you multiply is you multiply pairwise. So you do two things first and then multiply the other one. Doesn't matter, right? Based on the laws of continuity, doesn't matter which one goes first. I'll do the numbers first. Multiply these two first. So negative 6x. Then multiply by x minus 2. So distribute negative 6x squared plus 12x. So that's what goes here. Negative 6x squared plus 12x. And then now, add up like terms. The 8x and the negative 6x get me 2x squared. The 20 plus the 12 gets me 32x. All over 3x plus 3, x minus 2, 2x plus 5. And again, that's my answer. And this one I actually do want to check if I could reduce it. Let's see if something actually cancels out. I could factor out 2x from the top, and I would get x plus 16. So again, in this case it doesn't, nothing reduces again. But that one was closer than we most have gotten. That one might have canceled out afterwards. But so this is our answer. Okay, let's do the last one. It appears to be almost as long. Okay. So we got a factor. Now it looks like it has a number front, but they don't have anything in common, so it's another long factoring. So I'll do it here real quick and then I'll erase it. So multiply that first and last, so I get negative 24x y squared. I need two things to multiply to get 24, but I have to get 10. So it sounds like 6 and 4. To negative 24, those are different signs. So 2 and 12. So it's going to be negative 12x plus 12y plus 2y. Right, those two things multiply get negative 24, but when you add them, you do get negative 10. So again, all we're going to do is sub this in for the middle term. So that middle term is gone. Be 3y squared minus 12y plus 2y minus 8. Factor by grouping, my favorite type of factoring. These have a 3y in common, and we get y minus 4. Bring the middle sign down. These two things have a 2 in common, and you get y minus 4. Factor these out, you get y minus 4, 3y plus 2. So that's it, all factored. Y minus 4 times 3y plus 2. So let's go back here and write that before I erase all this. Okay, so this is y minus 4 and 3y plus 2. Other side, the last number of factoring. 2 these multiply to get 8, but I have to get 6. Y minus 4 and y minus 2. Okay, so now we can do what we normally do, right? I know what LCM is. I will know in a second. Right, what's this side missing that this side has? The y minus 2. Likewise, what's this side missing that this side has? The 3y plus 2. So my LCM is going to be this whole denominator right here. Y minus 2, y minus 4, 3y plus 2. And in the numerator, well, I have to simplify it. So let's do that. 12 into there. I get 12y minus 24. Over here, don't forget there's a negative in front, so this is like really a negative 3 into both of these. So I get negative 9y minus 6. Erase a little bit more of this. There we go. And then we're just going to add like terms. So 12y minus 9y is 3y. Negative 24 minus 6 is negative 30. All over y minus 2, y minus 4, 3y plus 2. And again, this does factor. I can factor 3 at the top, and I get y minus 10. But nothing cancels, so it had no effects. There we go. We're done.